Hello everyone, Dikko here with another kick-ass walkthrough. This is part 3 of a multi-episode series covering an introduction to rigging. In this episode we are finally going to start looking at building our rig, starting with the underlying deformation armature. We are then going to skin our mesh using some rudimentary weight painting techniques. Now if you want to follow along with the same robot arm I'm using, take the time to download the original file with the link in the description below. So let's jump right in with a little pre-planning. Now if you've watched my previous video, you would know that there are a few things to consider about the initial setup of an armature. One of the key things to make sure is that you've got your initial rig layout correct before we add any of the fancy stuff. So let's quickly cover that now. Alright, so I've got my file open here. As you can see, there's nothing else besides the mesh. Just want to cover a few basic things to consider before you start the armature process. Let's go with a few basic things first. So one thing you might notice is that my object itself is zeroed out inside the world space. So basically everything has to be sort of centralized to the X and Y axis. The other thing is that all your transforms on the mesh will be completely zeroed out, something that I mentioned in my previous video. The other thing to consider is that you put all your mesh objects into a single collection so you can keep it nice and organized. And also, if you want to, just make sure that you've named all your geometry as needed. When it comes to building the armature, there's a few things I would like to cover as well. So one thing to get used to and understand is the nature of the object you're trying to rig. So if you're rigging something that's mechanical or something that's organic, you need to take into consideration different points of articulation that that object needs to have. So in this case, we're using a mechanical object. So for the most part, or entirely in this case, our armature is very rigid. It's going to be very rigid. There's no smooth deformations between, say, the joints of the arm and the the length of the arm, for instance. Everything kind of has its own sort of space to sit in. The other thing to note is where the joints should be built within the rig. So, for instance, if you had an animal or like a dog or something, you'd need to know where the hips lie in that animal, where the center of gravity fits on that animal, in order to give it the animator a realistic sort of a realistic base to work from when they start animating. So in our case, because it's a static object mostly, there's no wheels, there's no legs or anything like that, we can start planning our rig from the bottom up. So we have the base of the rig sitting at the base of the arm, and then we sort of extend the joints outwards up the arm toward the fingers. So let's just break that down with a few notes. You don't have to follow me with this, just watch what I'm doing, and then we'll jump into the actual rigging part in a few minutes. So as you can see, we have our base of the rig here. And that's actually in 3 parts. So we actually have the base, the actual base here. And then we can have a potential point of rotation here. So this is the first point of rotation. Yep. So the nice thing about this base here is that it only has to rotate along a single point that is vertically, basically. It has to rotate around that vertical center of that object. And then we have our second point of articulation, which actually is the beginning of the arm. So here, the hinge, the first hinge sits here. And then we need to have that hinge influence this part of the object here. So this first hinge will influence this first chunk of the arm, right? The second bone that we'll add in the arm joint will be from this hinge here. So this will be the second hinge. Now notice how between these first and second hinges there's only one point of articulation, and that is basically horizontal along the point in which the arm can rotate. So it can't rotate in any other direction. So say if you have a priority to have it rotate on the X, you would lock off the Y and the Z. And here's where it gets interesting on the hand. So the hand actually is this whole chunk. And notice how we have a sphere at the top here. You think in some cases that you'd actually put the hinge here, but that's not the case. You actually put the hinge in the center of that ball, right here. So inside that center of the ball is where we'd have the hinge influence this entire block of movement. Because we want this actual blue part of the rig to sort of rotate around that ball as if it were sort of like the BB-8 robot in Star Wars. So that will be our third hinge. But rather than it being a hinge, it's actually a ball joint. So we can call it a ball joint. The third and final part, or I guess it's the fourth part if you want to call it anything, is the fingers. So the fingers are symmetrical, and that's really important to understand. So if you have a symmetrical rig in Blender and you follow the right naming conventions, you can actually make your life a lot easier in both the rigging process and the animation process. So we have two hinges at the base of our each point of articulation on the fingers. So we got hinges here. Forgive my shitty handwriting, I'm writing on a screen. Hinges on the fingers. And we essentially only have two knuckles, if you want to call it, if you want to have some sort of analogous thing to our own hands. Two knuckles. Right? And this setup, because we understood and broke down the actual flow of the mesh and how we wanted it to move, we can build our rig around those principles. So we know now that the base will influence the entirety of the rig, but then in a sort of incremental way, we will add more flexibility as we work up the rig. And this is basically the same principles you would give to any other kind of rig that you build, whether it's an animal, another robot, or a creature or whatever. You basically start from that center of gravity or that base of that animal or creature, and then you work in the complexity as you go along. So you start simple, start with the overall movement, and then work in that complexity as we work through it. So yeah, with that in mind, let's begin with the building out of our rig. Alright, let's get started. So the first thing we should do is make sure that our 3D cursor is set to 0. So let's quickly just do that. Just zero out all those values, sorry, number lock. Zero out all those values. And the same with the rotation, lock them all out. The second thing to do is to make a new collection. So we're going to make a new collection for our rig to sit in. So right click, new collection, and we'll call it armature. Robot arm armature. Yep. And now anything that we create, as long as our collection is selected, at least in 2.81 or 2.8, will be created in there. Alright, so let's create our first armature. Shift A, scroll down to armature, and select a single bone. Alright, so let's just go into our armature property settings here and turn on in front so we can see the rig at all times. I'm going to jump out of pre-rendered mode and just jump into our preview mode, into our viewport shading mode. And I'm going to go switch into side view. So to switch into side view, press 3 on your number pad so we can get an orthographic view of what's going on. Alright, so let's select our armature. Let's give this a new name. We'll double click on that. I'm going to give it the prefix rig _ robot arm. Alright, so I'm trying to keep things consistent here, so as long as we do that, it's going to make our lives a lot easier. Alright, so let's tab into edit mode with our rig selected and start editing our armature. Alright, so let's just quickly block out the layers that we need. So considering what we took notes on before, we can quickly sort of smash out a rough layout of our rig, and then we can refine it as we go. So we know that this base will need its own joint. So let's just do that now. So we'll just select the tail joint of our bone and then just shrink that down to the bottom there. Alright, now we know that this base is going to need its own bone as well. Let's turn on my shortcuts for you. Alright, and to extrude a new bone, we just push E on the keyboard, and then we can lock our extrusion vertically with the Z, pressing Z on our keyboard, and then we just drag that up to a point that we need it to be. So in our case, because the hinge is our point of articulation for the rest of the arm, we'll bring it up to the center of our hinge. Alright. And again, let's extrude all the way up to the next hinge. We're just going to extrude another joint out. So it creates a new bone all the way up to our hinge up here. And again, we're going to extrude because we know that the pivot of our hand is going to be at the center of this ball joint. We want to extrude the next arm joint up to the center of that ball. So let's extrude that again. Just click and drag and just roughly put it there. We'll clean this up as we go along. Alright, so we got our hand joint, our hand bone, sorry, and we'll extrude that upwards in a straight line up to the base of our fingers. Alright. Now, we know that our fingers are going to be symmetrical, right? So let's just tab into front view by pushing 1 on the keypad. We'll bring you into front view. Notice how, because we've been extruding our joints in orthographic mode, that the joints based on the origin point of our rig, it's being created basically in the center of the world, which is great for us. So that means that all our joints up and down our rig so far are basically sitting perfectly in the center of our world, which is perfect for our rig. But now we need to create some joints or some bones outside the center line of our rig. We need to create some on the side, outside of 0 point. So to make my life easier, I'm going to select this bone and duplicate it by pushing Shift D. And then I'm going to drag it to the side here, right? I know that it's going to be a 2 bone chain. So I need to subdivide this so it has a point of articulation on the first knuckle and then another point of articulation on the second knuckle. So rather than shrinking this down and extruding it, I'm simply going to subdivide it by selecting, right clicking in my case because I'm using the left click select, right clicking, or push W if you're using right click select, and select subdivide. And that will subdivide the bones perfectly to where we want them to be. Alright, so before we go any further, there's a few things we need to fix. And one of those things is, again, part of the rules that I listed in my previous video, consistent naming of our joints. So right now, as we've been creating our joints, it's basically just giving them the name bone. Bone 1, bone 2, bone 3. And if you're trying to be a consistently good rigger, that's horrible for us. So we're gonna go and quickly rename these deformation bones to suit our rig. Alright, so let's go back down to the bottom here. We got our first bone here. Alright. Switch over to the bone tab on the properties panel, and we're going to give this a prefix of DEF for deformation. So these bones are all going to deform our armature in one way or another. Alright. DEF base .001 for the first one. Our second one, I'm going to give this the name base 2 because it's kind of part of that same structure. So I'm going to call it DEF underscore base .002. And now you might be wondering why I'm putting 2 zeros in front of my numbers. And there's a reason. Blender likes it. Blender, when you create duplicates, it will just basically create the suffix 001, 002, 003. So I like to stay consistent with Blender's naming conventions as well. We got our first arm here. So you can call it anything you like, but let's be consistent. So I know that this is going to be arm 1. The next one will be arm 2. I'm not going to call it hinge 2 because it could be called hinge 2, but because I'm trying to be I'm trying to give each bone the right name to suit its function. So I know that it's basically functioning as an arm bone. Not necessarily a hinge bone, but an arm bone. So I'm going to give it the prefix DEF underscore arm dot 001. And I'm going to repeat that again in the second bone. DEF arm dot 002. Now this bone here, again, just use your common sense when it comes to naming things. Or if you're doing a very specific kind of rig for, say, like an animal that has specific arm parts or physiology, it might be good to actually name them according to, the actual physiology of the animal. So if they have like a dorsal fin, you might be worth calling it dorsal fin, for instance, Anyway, I digress. So let's just give this the name hand.001. Alright. And now that comes us here to the fingers. Now the fingers, because they're going to be part of a symmetrical mirror of each other, Blender has a very smart way to create symmetry in its rigs. It's down to the naming convention. So as long as you're consistent with the naming convention of Blender, you can easily symmetrize an armature accordingly. So I'm going to give this the prefix DEF finger dot L dot 001. And now the order in which I've put the nomenclature of .L .001 is super important to get that symmetry to work right, because Blender, when it mirrors joints, it doesn't mirror joints usually on the basis of its location in space. It mirrors the joints first and foremost on the naming convention of the joints. So as long as you have left and right, you should be able to mirror them almost in any case, as long as it's consistent. That being said, second finger, same name. You can actually copy and paste names as well, and it will automatically number the joints or the bones of that object. So just hover your mouse over the actual name, and you can just push Control C. And then if you select the second finger, and then hover your mouse over the name, and push Control V, it will automatically give it the number 002, and it will keep doing that according to the amount of bones you add to your rig. So if you want to have like an arm rig with 8 bones with the same prefix, it will automatically go 1, 2, 3, 4, 5, 6, 7, 8, as long as your naming conventions are consistent. All right. So with that in mind, we are now able to mirror these joints or these bones. So we'll just select these 2 bones and right click and select Symmetrize. And look at that. In the perfect place, exactly where the other ones are sitting. If you look at the actual item information and look at the head coordinates. Exact values, just mirrored with a minus value, which is perfect for us. All right. So we've got our base set up here, up and running. Now, there's one last thing we need to do, and one is to change the relationship of our finger from this joint, or this bone, to this bone here. And the reason why it's automatically created that relationship here is because we duplicated from this point, this bone here. So this bone already has a child-parent relationship with this bone. So therefore these duplicates also would have the same child-parent relationship. So we don't want these fingers to follow this arm joint. We want it to follow the hand joint, bone, sorry. So select the bone, select the hand bone, and check this out. If you go to your tool settings on the side here and have the checkbox x-axis mirror selected, it will automatically parent our mirror version of our joint, our bone, to the same bone. It will duplicate the functions that we're giving to these bones here, which is super useful. And again, it comes down to our naming conventions of our symmetrized bones. So with that being selected, let's select x-axis mirror and select our finger bone here, not the top one, just the bottom one, because the top one is the child of our first finger bone. We'll select our finger bone, select our hand bone second, and then Control P, and you'll get an option to have it connected or to keep offset. In our case, we want to have it keep the offset. Look what happens when I push connected. It actually connects itself to those bones that we've parented to. We don't want that. We want to keep its location in 3D space. So we want to keep the offset. So let's do that again, but with keep offset turned on. And you will see the relationship line changes from this bone to our hand bone. Alright, so let's just quickly tab out into pose mode and have a look at our armature as it sits. Let's just turn off our geo collection for now. I'm just going to turn it off in the screen, and let's have a look and see how this operates in pose mode. If you look at our transforms, you'll see that everything's zeroed out because of the way that Blender operates. It operates inside the armature object. The bones sit within the armature object, as I mentioned in the first video of our series. So therefore our transforms are already zeroed out, which is awesome for us. But let's have a quick look and see how this thing articulates. So with our base selected, our second base bone selected, I can rotate my entire arm. With the arm rig selected, I can rotate from the hinge of that first arm bone, and up the chain as we go through. Now check out this. This is one of my favorite things about animating in Blender, as long as you have the proper naming conventions with fingers and arms and stuff like that. If I rotate this joint here, this bone here, and it has a symmetrized bone over here, and I push copy, I've got a plugin turned on to give me more options, but if you just push Control C and then Control Shift V, it will automatically mirror our pose in pose mode. Best fucking feature ever. Alright, so with that done, it looks like our actual joint setup is looking pretty good. We can start to refine the location of our bone heads and tails to fit within our armatures. Because right now we did it pretty roughly, we just did it by eye, but we need to do it precisely, especially in the case when we're doing mechanical armature setups. When it comes to mechanical stuff, you have to be super specific about where those pivots sit. So let's get into that. Alright, with that in mind, let's just bring back the visibility of our geometry. And let's have a look at our setup in detail. So, I'm just going to pop into object mode and have a look at our wireframe of our objects as well. So I'm going to turn on inside the viewport overlays, I'm going to turn on wireframe. Okay. So, let's get down to the nitty gritty of our points of articulation. Alright, so we know that this, for instance, this base is already pretty much good to go. We've made our rig from the 0 point in space. We've made our rig from 0 point, so therefore our rig is already set up there. But if you look at how close we are with our armature, if we zoom into our hinge, for instance, you'll notice that our first joint of our arm bone isn't completely centered to the hinge. And that can create some odd offsets, especially when you're doing technical rigs that require that little of specificity when it comes to articulation. So we actually have to move these points to in a more accurate location. So let's get into that now. Alright, so looking at the first base, this one looks a little bit too low. So let's go into edit mode, and just this one we can kind of do by eye because we're only going to be rotating from the base on a vertical. So let's just bring that up to line up perfectly with that base there. So just line it up with that base of this chunk here. Now, when it comes to these stuff like hinges, we have to be a bit more specific, and this is where the 3D cursor really shines. This is what makes the 3D cursor awesome. Obviously, when you first open up Blender, it happened with me as well, you start moving around the 3D cursor by accident. I'm like, what the fuck does this thing do? It's absolutely getting in my way. But once you learn to harness the power of the 3D cursor, it becomes an essential part of the Blender workflow. It is absolutely awesome. So in our case, we want to get this hinge perfectly centered, right? We know that this object here is perfectly centered in the 3D world, right? Unfortunately, our point of origin is centered down here. So if we move the 3D cursor, assign the 3D cursor to match the location of this hinge, it will go to the center. But we can actually move the 3D cursor to the center point of this object here. And then we use that 3D cursor to move the head joint of our armature in the base of our hinge to that point. And it's absolutely perfect every single time. So with that in mind, let's select this hinge object in object mode. Let's go into its edit parameters. And notice how we have a ring of geometry that is dead center to the world. We can also notice that because this thing is absolutely symmetrical from the get-go, we can actually select the entire object and then push Shift S, cursor to selected. And look at that, our cursor is dead center with our object that we have selected in edit mode. Let's get out of edit mode and back into object mode and tab into our side view using 3 on the keyboard. And you'll notice our 3D cursor is dead center with our geometry. Now, if we go into our rig, select our rig and go into edit mode and then select this joint of our rig and push again Shift S, but instead of saying cursor to selected, we go selection to cursor, it will shift that joint perfectly center with that object. And now our job is to do the exact same thing along the entire joint chain to make sure that our point of articulation is absolutely perfect with our rig, with our geometry. Now again, jump out of object mode. We know that the next hinge is up here. We have to do the exact same process with this hinge. And again, notice how our point, you might not see it on the screen, but our hinge joint is completely off with the actual hinge center of the hinge. So tab into edit mode with the object selected, and we're going to go select everything by pushing Shift A, or sorry, not Shift A, just A, then Shift S, cursor to selected. Tab into your bone chain again, select the joint that we need to move into place, so notice how it's off. Shift S, selection to cursor. Perfect, aligned perfectly, no bullshit required. No snapping, no judgment calls, no tiny little indiscrepancies. It's perfectly centered. And we just repeat this process up the joint chain where necessary. So especially this ball joint, because we want this thing to rotate perfectly around this ball, we need this joint to be perfectly centered. So select the ball in object mode, tab into edit mode, select all by pushing A, and then Shift S, selection to cursor. Oops, not selection to cursor, see what happened there? We want to go cursor to selected first, bring up that 3D cursor, tab out, open up our armature again, tab into edit mode, select the joint, the head, Shift S, selection to cursor, perfectly centered. Now notice if we jump into pose mode, just quickly, and we can rotate. See how that joint is perfectly rotating around that ball joint? Super important for us going forward. Now for the end of our hand joint, it's not that necessary to be accurate. As long as it's centered within that sort of circular parameter, it's not that necessary because our finger joints have their own hinge origin, and they have their own offset from that point. They're just children of this joint. This joint is more of a structural deformation than it is a mechanical one, because it's the end of the joint chain effectively. Bone chain, sorry. So that one can kind of stay where it is. But let's just pop open into edit mode anyway and see how this aligns. So we know that this ball joint has moved. Notice how if we just jump into out of octahedral viewport display, it's in the armature properties, and we change it to stick, notice how it's not actually fully aligned right across the bone chain between the head and the tail. We kind of want this tail to be perfectly aligned because it's such a symmetrical and zeroed out armature. We want this to be perfectly aligned. And we can do that relatively easily by using our transform properties inside of edit mode. We know that the tail, this is the tail up here, has its own coordinates. It's something we mentioned in our first video. We know that the base of our bone, the head, has coordinates already locked in there. We don't want to change the head, but we can change the tail. Okay? So with X is already perfectly centered, so that doesn't matter. If we move it in Y, notice how the coordinates change. So let's copy the Y value from our head, hover your mouse over the Y value, Control C, and then paste it into the Y value of the tail. And notice how now our bone is perfectly straight for our armature. Absolutely perfect. And we need to do the same thing for our finger joints, our finger bones with the hinges. So we'll do it with the 3D cursor. So let's just get out of into object mode, select our first hinge, edit that in, and now notice this is the magic of both symmetry and naming conventions and the 3D cursor working in tandem with one another. So I've got my first hinge selected with all the geometry selected. I push Shift S and the cursor to selected. The cursor is perfectly centered now to that hinge. Let's jump into edit mode of our armature. Now check this shit out. Now, before we move to shifting this hinge, we're going to change the transform properties, the pivot point of our bones. So I want to change it from local to normal, and from individual origins to active element. I think that will work. Yep, active element. So now it's going to shift the entire bone rather than just the tail across to the 3D cursor. So if I have the whole bone selected and I have these properties enabled, it will shift the whole thing in a straight line. I won't have to do that edit like I did in the hand. Alright, so Shift S. Now notice how both the left and the right bone will shift when I do this because we have symmetry enabled. Selection to cursor, and boom, both have changed. Absolutely brilliant. But notice how by doing that, it didn't move the child bone. That can be solved if we select the child bone first and then the parent bone of our fingers. And with active element, so we're actually transforming our entire selection based on the active element of our selection. So the last thing we selected, and we do the same thing, Shift S, selection to cursor, it will move the entire joint chain, which is perfect for us. That being said, we still need to change the pivot to be centered in this hinge. So again, let's just tab into this object, Shift S, cursor to selected, tab back out into our pose, to our bones, jump into edit mode, select our last joint, and now Shift S, selection to cursor. Oopsie, wrong way around. Yeah, selection to cursor, sorry, there we go. And now we're good to go. Perfect. So now, in a matter of minutes, we have aligned our entire joint chain to fit with our armature, with our mesh, sorry. Now, all we gotta do is skin this motherfucker and move on. Okay, so this is where the fun begins. The skinning process, or the bind process. This can be a bit tricky for those who are trying this for the first time, but this is where patience is key. I'm gonna take it in a more technical approach with this because we are using a technical rig. So therefore, stuff like weight painting and all that kind of jazz, it can be pretty frustrating, especially when you are doing weight painting for multiple objects. So I have a method for this particular rig. It's a great way to understand how the skinning method works in Blender as well. So let's just get into that. But normally when you skin an object or add the deformation rig to your mesh, you basically just automatically bind with automatic weights. That's great for organic sort of objects, but for technical objects like this, it can be a bit tricky. But let me just show you what happens when you do it that sort of traditional way, where you just bind straight to the rig automatically. So to do that, select all your mesh objects first, and then just make sure you have your rig selected last. And then push Control P on your keyboard, and then set parent to armature deform with automatic weights. And let's see what happens when we do that. Obviously nothing has really happened, but it has bound the object. Now, if you had transforms on your rig when you had bound the object, you would see the mesh would have moved. But in our case, luckily, because we had planned this properly, we didn't get that happening. So if we jump into pose mode and select one of our bones, you'll see it's rotating pretty good, but we are having some issues. Notice how we're getting some crunching on that hinge. Now, I don't know about you, but a mechanical hinge shouldn't crunch like that. You seeing that, how the geometry is sort of being affected? And that's because the weights have been distributed between this bone and this bone, and it's causing some issues. So rather than doing it in that way, we're going to bind this thing with some empty weights, and then we're going to assign the vertex weights manually. Hope that makes sense. So just click on all your armature pieces. Alright, so make sure if you've done what I just did then, that you delete the vertex groups all completely. So I'm just going to delete them quickly now with every object. Unfortunately, because I have multiple objects in this armature rig, it's created the vertex groups already. So I'm just going to quickly do that now. I'm going to delete them all by pushing the mesh, and inside the object data panel, I'm just going to select delete all groups. I'm just going to do that with everything, just bear with me. I've also got these groups because I actually used this mesh to build the initial rig in the supplied file that I gave in the link below. Alright, cool. So if you've done that, you may have had some vertex weights on the file that I provided as well, because I use that as well as a base for the file that I supplied. So maybe if you went through and just deleted everything by hand as well, that'd be good. Anyway, so now if you look at our rig and our mesh, you'll see that there's no vertex groups, and the only modifiers we have are, you know, they should just have whatever modifiers I gave in the supplied file. So no armature nodes should be already on there. So delete those if in case there are any there. Alright, that's all good. Alright, so what you should have is your armature with no vertex weights, no armature modifiers on there. We're going to select our mesh, and then we're going to select our bone chain, our armature object, and then we're going to push Control P, but this time instead of saying automatic weights, we're going to go with empty groups. And look what happens when I push empty groups and I try to articulate the armature. Nothing is happening, and that is for good reason, to be honest, because we're going to manually add the weights ourselves. And to do that, we go into each object and then assign the weight to that particular bone that we have for that particular object, because we have a mechanical setup here. Now, by default, if you have other modifiers on an object, particularly subdivision modifiers and bevel modifiers, you want to make sure that the armature modifier sits on the top of our stack, not below the subdivision or bevel modifiers, because it actually adds to the calculation, and it also causes the weights to not distribute very well, and it makes it super hard to weight paint as well. So what you want to do to improve performance and to make your life less of a living hell, bring the armature modifier of each object to the top of the stack by pushing this button here. So you want to have your armature modifier sitting on the top at all times, for most rig setups. Alright, so with the first object selected, I've moved my armature to the to the top, sorry. And now let's go into our vertex weights and see what's happening here. It's actually created all the vertex groups of our rig based on the naming conventions we've given our armature bones. And now this is why naming your armature is super important. Now what we can do is basically just assign the weights of our bones 100% to each object as we need them to. Very, very, very cool. So rather than painting it manually, in this case we're going to go with a more technical approach. I'm going to tab into our object that we have selected. In this case it's the base. And because the base has been given a bone assignment of base, we can actually go and assign 100% weighting of that base joint to our base vertex group. So if I assign that, and that's all we need to do, just assign it 100%. We do this with the same, the next object, because we're going up the joint chain, we're going up the bone chain, and we've added that complexity as we've built our setup and we've named everything properly. We can just go back into tab into this object, select everything. Well, first I gotta select everything, and then because I know that this bone is called base 2, I can assign it 100%, and that's all I need to do. And I'll just keep on going. In this case, because it's the hinge object, we can do either the base object or the arm object, but in my case I'm going to go with the arm. So tab into edit mode, select all my vertices, and then select arm 1, assign. And I'm going to keep on going up our chain until we get to the end. So in our case, the arm joint, this arm mesh is assigned again to arm 1 because it's part of that hinge, arm 1. I'm going to click on that. Next hinge is the second arm, part of the second arm, so arm 2. Assign. Select. Make sure you select the entirety of your mesh. So press A to select everything. I'm going to select arm 2 again for that joint. Now this ball joint I don't want it to rotate. This is more of an articulating structural object, so I actually want it to be a child of my arm. It's only the top of the hand that I want to be assigned to the hand. So in this case, tab in, arm 2, assign, tab out. Again, in this case it's a hand, tab in, select everything, hand 0, 1, assign. We're going to do the same thing for the hinges now. Now notice that we have, when we mirrored our joints, our left side, it actually automatically named the right side of our armature as well. So we know that this is the left side, so we're going to give it the assignment of finger L.001. So tab in, select everything, finger L.001, assign. And again, hand, finger L.001, assign. In this case, it's the second hinge. We're going to go with 002. L, assign. Finger L.002, assign. And then finally, our last objects, we're going to use the right side. So finger R.001, assign. Select all of them again. R.001, assign. Deformation finger R.002, assign. Select everything. Deformation R2, assign. And now we essentially assigned our weights without really doing any weight painting, because we named our joints appropriately and we've named our armature objects, as in our mesh objects, appropriately as well. One last thing you need to do, just make sure you've got those objects that have been rigged with the armature modifier at the top of the stack. So go through the actual objects and move those armature modifiers to the top of our modifier stack. Won't take long, just be conscious of it. Now that that's done, it will perform a bit better. You won't have to have that additional calculation on top of all that subdivision and bevel. You can turn off the bevel and all that sort of stuff and it'll be fine. So let's try and articulate our rig. Holy shit, we got perfect articulation. Look at that. Look at that. Now check this out. Because we've added the pivot perfectly in our hand joint, look at that. It's perfectly rotating around that hand, that ball joint. Exactly what we want it to do. We've got our finger joints working properly. Way awesome. Do that again. Cool. Cool. And look how we're not getting any crushing on our hinges either. We're getting perfect articulation. Look at that. Fucking awesome. And this is why it's important to plan your rig. Once you've planned your rig, you can do shit like this without really bothering with anything. Now notice here that the object, if I pivot this part, it does some weird shit. That's only because we haven't locked off our transform. So when we come to the mechanical part of things, we will start to lock off things. So for instance, like I said at the start of this tutorial, this base joint should only be affecting the vertical rotation. So in this case, if I look at the normals, Y is up. So therefore only Y should be available to be rotated. So if I just lock off X and Y, lock off the scale, look at that, perfect. And then of course our base joint will affect everything. Look at that, absolutely brilliant. And it's scaling properly because we've used our child-parent relationships properly. And that's all we need to do for now. That's all we need to do. There's no weight painting in this tutorial because we don't need it. And that's why it's important to make sure that you have your rig centered out properly where needed. That if you're doing technical rigs, that you've got your pivots sorted out as well, and that you've named your joints appropriately. And then suddenly that whole issue of weight painting, at least in a mechanical sense, is absolutely moot. Pointless, you don't need to do it. And now, in a matter of minutes, now we're ready to go and start working on our mechanics. But we'll wait to do that in the next tutorial because it takes some time to really understand how this thing works before we move into the mechanical side of things, because we can start to do our FK and IK joint chains, our global controls, our shapes and all that sort of stuff in the next tutorial. But for now, that's all we need to do. So until then, catches.